Okay, so we're looking at question 9 from the 2014 exam. Okay, so by introducing slack variables and artificial variables as appropriate, and using the Big M method, we aim to write down the first tableau of the simplex algorithm of the following LP problem given here, and we write our answers in the tableau given. And finally, we'll circle the entry that we would pivot on once we've written up our first tableau. And we're given the handy note that we don't have to solve this LP problem, which is nice. Alright, so let's have a look at the LP problem we're given. So in this case, we're given a minimization problem and a set of constraints here. Now in the form that it's in, this minimization problem isn't as useful to us as a maximization problem. So we can quickly rewrite this as a maximization problem. So let's do that now. So we've got maximize minus z, which is just equal to minus 1 multiplied by this side as well, which is 9x minus 17y. Okay, now we just treat this as a maximization problem. Okay, so firstly, we have a look at these numbers on the right hand sides of these signs, and we want them to be non-negative numbers. So that means this first constraint has to be rewritten, and we do that by multiplying both sides by -1. So we have minus x plus 7y is greater than or equal to 6. Okay, so now each of these numbers are non-negative numbers on the right hand sides of the greater than or equal to signs. So now we want to change these greater than or equal to signs into equal signs. And we do that by introducing our slack variables and artificial variables. Okay, so now let's rewrite these constraints that we're given. Now the first constraint up here can be rewritten as minus x plus 7y, and now we introduce the first slack variable, which is s1, and give it a -1 for its coefficient, and then we add the first artificial variable, r1, and that equals 6. And now to rewrite our second constraint, so we have 5x plus 8y minus s2, which is our second slack variable, plus r2 equals 5. And finally, our third constraint rewritten is 2y minus s3 plus r3 equals 3. Now if any of these were less than or equal to signs, we wouldn't need to give ourselves a slack variable and an artificial variable, and we'd only give ourselves a slack variable with a coefficient of +1. But in this case, we've got all greater than or equal to signs, so we need both the slack variable and the artificial variable. Okay, now the next part of the problem involves using the Big M method, and what we do is we aim to maximize our objective function, but our objective function, which we'll now write as w, is still minus z up here. And now we want to include our Big M from the Big M method up here to help us drive out our artificial variables up here. So we do that by giving ourselves Big M, which is some large positive number, and then multiply that by r1, r2, and r3, and then give ourselves a negative sign, which then makes that an unfavourable part of our new objective function, which is w. Okay, so rewriting w out properly, so we still have -z, which we just substitute in, which is 9x minus 17y, and then we just substitute in r1, r2, and r3 by making them the subjects in constraint 1, 2, and 3 respectively, and then making the necessary substitution. So skipping some working out, this equals plus m for x plus 17y minus s1 minus s2 minus s3 minus 14. Okay, so again I've skipped some working out here, but I've just done this in one step to save some time. But this should be the answer you get after doing the working out and the substitutions for R1, R2 and R3. Alright, so now to start filling out our tableau here, I'll firstly give ourselves variables up the top here and a W down here. Okay, so here are our variables, and notice I've given myself a bit of extra room for the X and Y columns when compared to the slack variable and artificial variable columns, and I'd advise you do the same, and I'll show you why I've done that in a little bit when we fill in our W row down the bottom. Okay, so firstly, let's look at the first row of our tableau here, which will correspond to the first constraint that we're given. Okay, so let's fill in the coefficients in front of each of the variables. So we have minus 1 in front of x, 7 in front of y, minus 1 in front of s1, and zeros for s2 and s3, 1 in front of r1, and then zeros for these two as well, and then 6 at the end here. Okay, and same again for the second constraint and our second row of the tableau. So we have 5, 8, 0, minus 1, 0, 0, 1, 0, and then 5. And lastly, our third row and third constraint, we have 0, 2, 0, 0, minus 1, 0, 0, 1, and 3. Okay, so at this time we can fill in this left-hand side column here as to what our basic variables are, and they're simply in this case R1 for the top one, R2 for the middle row, and R3 for the bottom row. Okay, now we're up to filling in this W row down here. So we do that as we would normally for any maximization LP problem. So we have 9x, and also notice we have 4 times m times x here as well. So the corresponding value that we plug into this entry down here is minus 9 minus 4m. Okay, and now to do y, so we have 17 minus 17m. Okay, now for s1, we have minus m s1, which will be m, and same again for s2 and s3. Now r1, r2 and r3 don't make an appearance, so there's zeros for those entries, and then finally we have minus 14m for the bottom right hand corner entry. Okay, so now you can see why I needed just that little bit more room for our X and Y columns, as it can be a bit crowded if you don't give yourself enough room. Okay, now finally, we've finished our tableau. Now there was one last thing that we needed to do, which is up here, and that is circle the entry that we would pivot on in our initial tableau that we've written up here. So how we do that is firstly, we look at the W row that we've written in, and we want to find the most negative number in this row, and in this case, because m is large and positive, the most negative entry will be this entry here, as we have minus 17 times our large positive number when compared to just minus 4m here. So we don't really notice the 17 and minus 9. The main thing to look out for is the most negative number multiplied by this large positive number m to find which one is the entering variable. So in this case, that is y. So finally, we have to look at the ratios 6 on 7, 5 on 8, and 3 on 2. We have to find the smallest non-negative ratio, and in this case, that's 5 on 8. So our pivot element will be this entry here, this entry of 8, and hence R2 will be the departing variable. But we don't really need these arrows. All it asks for is to circle the entry that we'll pivot on, and that's this one here. Okay, and that's all we have to do for this question.